In this problem, we have a rubber tube with a length L with a total mass of m is fastened to the ground. So this is the rubber tube. A cord attached to the other end of the rubber tube passes over a pulley. This one is the pulley. And supports an object with a mass of 4m. The tube is struck a transverse blow at one end, so it's struck either here or here. Find the time expression for the pulse to reach the other end of the rubber tube. As you know, when you struck it, from one end a pulse is generated and it travels towards one end of the rubber tube. So we also note that there is no movement here. The acceleration here is 0, so it's in equilibrium. So the mass creates a force pulling this rubber tube by some force F, or for this case it would be the tension. So we need to use certain equations what we learned about forces in order to solve this problem. So, as we said, the rubber tube experiences a force coming from the weight. So the weight of the object. So we can draw a small FBD here. So you have point mass for the 4m block. You have the tension and the weight. So this tells you that if we sum the forces along the y-axis, tension is going upward minus the weight going downward is equal to 0. And if we rewrite it, the tension is just equal to the weight, which is equal to the mass times gravity, and for the mass is 4m. So we have this expression for the tension. Note that the rubber tube is stretched and it's struck at one end, so it travels from it. So we recall the expression for the speed of sound, as shown here in equation 3. So the speed of sound is just equal to the square root of the force divided by the linear mass density. And the linear mass density is simply the ratio of the mass of the rod or the rubber tube, mass of the rubber tube divided by the length of the rubber tube, which we can get because they are given, so it's just mass over the length. So substituting this function here, we get the expression for the speed of sound in the rubber tube here. So simplifying this further, we get this form here, and we note that the tension, the force, is just given by this expression which we obtained earlier. So substituting that, and this one cancels here, and the square root of 4 gives you 2. So it gives you the equation 5 for the velocity. Now we recall that velocity is just the distance divided by the time. We know the distance of the rubber tube is just L, and the unknown parameter which we want to solve is t. So substituting that one, and we get this expression here. Rewriting, we arrive to an expression for the time for the pulse to travel from one end to the other end, which is equal to the L equal over 2 times the square root of GL.